afternoon.
Good.
We'll see for some time and then we'll start.
Ma'am, let us start.
Yeah, okay. I'll share my screen. Can you all see my presentation? Hello? Can you all see my presentation?
Yes, madam.
Okay. So, can someone brief what was the content of week 3? Just broad topics. Can someone tell? Okay, I'll go into the presentation. So in the week 3, the overall content was about the recovery of the metals using various processes and the various e-waste management rules. Okay, so first we'll see the various recovery processes. So what are the main options for the treatment of the electronic waste? Those are the reuse, remanufacturing and recycling, as well as incineration and landfilling. The recycling of electronic waste is an important thing, not only from the waste management point of view, but also the recovery of the metals, valuable materials and metals from the e-waste. Because the metal content is around 28 to 30%, and many other components are also present in it. So this is the overall process description, that is disassembly, upgrading and refining. In the refining processes, we have this pyrometallurgical, hydrometallurgical and biometallurgical processes. We will see one by one what are these processes are. And this is the schematic flow for the various options of recovery of the metals from the e-waste. So when we have the e-waste, we do the manual dismantling and then the size reduction or the shredding, and then we have a physical separation by gravity, magnetic, electrostatic and eddy current separation for the various metals and heavy lighter fractions and ferrous and non-ferrous fractions. This is followed by the hydrometallurgy or the pyrometallurgical process, followed by electrometallurgy, where the precious metals are recovered. These are the various e-waste existing recycling techniques, that is CRT recycling, glass to glass, glass to lead, metal recovery, then precious metal recovery, pyrometallurgical and hydrometallurgical processes, and recovery of metals from the mobile phones. This is a particular company's physical separation flow sheet for the recycling of the scrap IC boards. You can go through the flow chart of this, it's a simple one. And this is one more copper smelting flow sheet for the recycling of scrap IC board. And this process flow chart technology was developed by the CSIR NML Jamshedpur, where various methods are involved in this for the extraction and recovery of the metals. If you look at the pyrometallurgical processes, it involves high temperatures to extract and recover these chemicals. It involves incineration, smelting in a plasma arc furnace or a blast furnace. Then it's a traditional method to recover non-ferrous metals as well as the precious metals from electronic waste. In this process, the crushed scraps are burnt in a furnace or in a molten bath to remove the plastics. Then refractory oxides from the slag phase together with some other metal oxides. So there are 2-3 processes that are described under pyrometallurgical processes, that is the Noranda process, Ronskar smelter process. Yeah, these two are some of the examples of the pyrometallurgical process. Then if we go to the hydrometallurgical processes, instead of high temperatures, we have leaching solution, that is helpful in extracting the metals from the e-waste. So it has a series of acid and caustic leaches of a solid material. The solutions are then subjected to separation and purification procedures, such as the precipitation of impurities, solvent extraction, adsorption and ion exchange. The final treatment is done by electro-refining process, chemical reduction or crystallization for the metal recovery. In this way, I have various types of leaching by using different chemicals. So we have cyanide leaching, halide leaching, thiourea and thiosulfate leaching. And by solvent extraction, we can recover the precious metals by either activated carbon, ion exchange, etc. These two are physical and chemical processes of extracting the metals from the e-waste. We have one more bio-related metallurgical processes where microorganisms are used to serve the same purpose as the chemicals are serving in the other two processes. So in the biometallurgy, we have bioleaching and biosorption, and the bioleaching can be either direct leaching or indirect leaching using any thiosulfate pathway or polysulfide pathway. This is a hybrid technology where we combine biometallurgical with any other method to get the metal recovered. So coming to the conclusion, the recycling of electronic waste is an important, not only from the waste but also metal recovery, and biotechnology has been one of the most promising technologies in this recovery process. Biosorption is a process that is based on a number of advantages because we have low operating costs and minimization of the volume of the chemical and the biological sludge that is to be handled post recovery, and high efficiency in detoxifying the effluents as well. Now, whereas the pyrometallurgy has some challenges from the environmental consideration because of the temperature and other criteria. The thermal processing of e-waste provides an approach for recovery of energy if a comprehensive emission control system is installed. And as we have seen, thiourea and all are a bit costly processes compared to other things. So we need to look at the cost aspect as well. Coming to the hazardous and other waste management rules. These rules are applicable to every manufacturer, producer, consumer, bulk consumer, collector, dealers, and other many people that are involved in the processing of e-waste and other electronic and electrical equipments. So what are the objectives of the rules? That is to minimize the illegal recycling and promote safe recovery operations by channelizing the e-waste to registered e-waste recyclers. As we were discussing in our previous sessions also, we have informal kind of recycling more in our country, and there are some only very few authorized private recyclers registered under the government. So we need to legalize all that. Then extended producer responsibility has to be put in place to manage the system of e-waste collection or taking back policy by the company itself, and reduce hazardous substances in electrical and electronic components, and to regulate the generation, collection, storage, transport, import and export, etc. What are the various responsibilities of a producer and a consumer? That is the prevention, minimization, reuse, recycling, recovery, and finally the safe disposal. These are the various e-waste management companies in India that have been doing very good recycling of the e-waste, and it was explained clearly in the content. So I am not going into the details of each company. Even if you Google, you will be finding many other companies that are now starting to develop on this e-waste management. So with this, these are the broad areas that was covered in the week 3 content. So we'll see some of the questions based on this content. So we go with the first question. What is the correct sequence of recycling e-waste?
Ma'am, A is the answer.
Yes. We C is the answer. Magnetic separation of the metals is characterized as what separation process in the metal recovery?
Physical, ma'am.
Yeah, it's physical. It's magnetic separation will separate ferrous and non-ferrous, so it's a physical separation process. Then purification of materials in e-scrap recycling takes place at what stage?
B, ma'am.
Yeah. Next question. Aluminium metal is separated from non-metallic materials by using what separators or what instrument?
Eddy current, ma'am.
Yes. Thiourea leaching is used for the recovery of which metal?
Gold, ma'am. Gold.
Yeah. So the Noranda process of metal recovery from e-waste is an example of what metallurgical process?
Pyrometallurgical process.
Yes. So we have Noranda and Ronsker smelter under pyrometallurgical process. Which of the following is used to separate metallic gold from a mixture of metallic gold and silver chloride?
Sulfuric acid, ma'am.
It's nitric acid. So which of the following statements is correct for the pyrometallurgical process? You can go through the statements and you can select one or more.
C, ma'am. C is the answer.
Okay. Any other? Yeah. So we have only one correct statement, that is the partial separation of the metals. Then of these statements, which is the correct one about hydrometallurgical process?
D is the answer, ma'am. D. All.
Okay. Yeah. So what is the ideal pH range for maximum dissolution of gold, platinum, palladium and silver in cyanide solution?
Ma'am, C is the answer, ma'am.
I think it's 10 to 10.5. Which of the following factors affects the efficiency of biosorption process?
It is, ma'am, pH of the solution.
Okay. So all these are correct. So surface charge of the biosorbents, pH of the solution and complex formation. All these impact the biosorption process. So with respect to bioleaching, please select all the correct statements.
B and C, ma'am.
Okay. Yeah. So which of the following statements are correct for a hybrid technology?
A. Ma'am, only one answer is correct or more?
Only one. Sorry, 2. Which of the
Ma'am, how to recognize that whether the question is having one answer or two answer, ma'am?
First thing, we can have a cross verification on the correct statements. If we feel if more than one are correct, there's no wrong in giving the other one also as correct.
No, ma'am, but initially it should be mentioned, no, you have to correct more than one. Otherwise, how to judge? I have to choose one or two.
Tiwari, it is usually a radio button. It's circle. Circle means one answer. And if you have multiple answers, usually it is a box, the square box.
Okay.
In the exam, this is how I gave my previous exams.
Okay.
And this is usually the case in when we give our assignments also.
No, but in this there is no circle and no square.
Ma'am is not. She is teaching us. So
Okay.
when we go for the exams, usually it is when you have a round, what we call a radio button. It is only a single answer there, and when you have. Sorry, ma'am, can I just explain if you don't mind?
Yeah.
Can I just explain?
In your
Yeah.
online submission, you can check.
Yeah, and when you have multiple choices, you have a square button. And in the multiple choices, if you make a wrong choice, then it goes for negative marking. You get a 0. If you have chosen, so let's say there are 3 correct answers and you have chosen 2 correct answers, you will be given what you call a pro rata marking in that. That is how it is done, Mr. Tiwari.
Okay, thank you.
Welcome, sir. Welcome. Sorry, ma'am. Sorry to disturb you.
No problem at all. Okay. So, with respect to BIOS option, again, what are the correct statements in this? Okay, can we see the answer?
Yes, ma'am.
So this has 3 statements as correct. Biomass is used for BIOS option, and then chitosan is an effective BIOS option of precious metals because of its higher adsorption capacity, and it's a derivative of chitin. Which of the following statements are correct with respect to BIOS option again?
In D, ma'am. And
C also. We have seen that, right? We have very little amount of sludge to handle.
okay, sludge would depend on. But sludge generation is one of the major things you'll have to address.
But in chemical, it will be more, right?
There would not be any chemical sludge. Basically, you'll be having only when you do bioabsorption. When you do bioabsorption, basically it is bacteria which is consuming the metal or whatever it is, and as a nutrient, and coming down and forming the sludge.
Yes, we have only the bacteria, but whereas if we compare it with the chemical processes, we will be having chemical precipitations and other
Okay.
chemicals.
Okay, ma'am.
Okay, yeah. That's it from my side. We can proceed for any questions if you have.
One question, ma'am, is because don't mistake my saying so.
No problem.
In 2011, when the lectures were on, it was 2011, the waste management rules.
Okay.
And some of the questions in the assignment were from the 2011 rules. Questions in the assignment.
Okay.
And the present rules are 2022. The latest waste management rules are 2022. So from the examination point of view, others may be interested. Are we we going to get questions from 2011, 2016, or 2022? Because reading a rule for historical purposes, okay, but for knowledge or for practical purposes, 2022 would be the right choice. I feel so. But anyway, I mean, it's left to the examiner. It's left to the examiner.
But even though the rules are amended, there may not be major changes. But maybe for your understanding, you can just have a comparison between both the rules and see what is the change.
Okay. Because in 2011, I think small industries and small and medium industries were exempt from the e-waste management rules.
Okay.
I have not read the 2022 rules, but anyway, so if there is a change in that, might be.
So mostly, I think if we focus at 16 and 22, that would be more than enough.
Okay. And now can you just go to slide 1 if you don't mind?
Yeah. This one?
No, the questions, man. Questions.
Yeah.
Upgrading means, sorry, I didn't get what upgrading means. Disassembly is okay. I mean, you're taking a part apart, taking a machine apart. Upgrading,
Okay. 1 minute, I'll tell you.
sure.
Generally, upgrading means making it into a better product.
Okay. Okay, so that you can reuse it for a further period of time.
Yeah.
Okay, thank you.
Today, very few people have joined.
You should be, don't miss everything. So again, you should be happy at least there are 3 people here. In other courses, there are just 1.
Okay.
Basically, it is a time, I think. It is basically the time of the what do you call it? Session.
Even if it's for working people, because it's Saturday afternoon. Because even the other session, my core TS session is on Monday, I think, Monday evening.
Okay. Monday evening also, the one session yesterday, there was just me and the TA.
Okay.
On Monday, I think, again, the attendance was again very poor. And there was one more session which was between 7 and 9, and there the attendance was better. Because again, city travel, you finish your work at about 5 or 6 o'clock. By the time you get home, like there's a news in today, and Bangalore is one of the slowest cities in the world. So, you could actually, I mean, if you could talk to them, you could bring down the sessions to 1 hour. 1 hour.
Actually,
And
till the previous semester, we had sessions till 1 hour only.
1 hour.
Now only they have increased it to 2 hours.
Yeah, and you could, I mean, then postpone the session to, instead of 3 to 5, you could postpone it to 4 to 5. Sort of. That would be, you could maybe have better attendance in this.
but for now I don't think so I can change
And
this.
we can't make any changes, ma'am.
Yeah, because only
But
this
thank you for
one.
your presentations. But thank you for your presentations.
No problem.
Very well presented. Thank you very much. Lot of material you got. Thank you very much.
Okay, no problem. Any other questions? Okay.
In all this bio-leaching and all, how to remember these all equations?
You don't have to remember any equations as such. You just have to understand what is it.
And how to remember which metal is extracted by which bio-leaching, what you say, fungal or bacteria? How to remember that, man? We are not from biology.
Okay. Even as such, even I am not from biological background, but simple understanding on how the process is happening or the technique involved in it, maybe that should help in remembering that.
No, ma'am, like you said, ki fungi is there, then bacteria is there. So these are all bio-leaching. So which metal will recover by fungal? Which metal is recovered by what you say, bacteria? So that type of understanding, at least little bit we require, ma'am.
Yeah, like if you can go through the slides one or two times more and understand like why the particular metal is getting leached in this way or with that particular bacteria. Or you can have some small code words kind of where you can relate which metal to which bacteria. For your
That code
understanding.
word, ma'am, you are the researcher. That code word, please give us.
No, if you develop on yours, for example, gold is recovered by thiourea. So something so GTU is gold thiourea. So something like that. Small words, keywords. If you can develop on your own, that will help you remember you more than me giving it.
Sorry, ma'am. This is you said how to remember. But why gold from thiourea? That some logic is there. Some science is there behind that.
It should be there, otherwise people must have worked out various metals and with various processes, and they must have finalized this, no? So the gold is has a better recovery by this process.
Like reactivity is there, na? Electrochemical series reactivity is there. So similar type of say some what you say literature has some sequence by like which precious metal is linked with which bacteria or fungal like that. If you are a researcher, then if you can give us.
Okay, I'll try to check.
Thank you, ma'am. Thank you.
Okay.
But ma'am, thiourea is a chemical process of leaching, and in when you do wastewater, it is not one organism which is put into it. Basically, what people do is when you uh, want to extract metals, because there are heavy metals in your waste. You've got different metal types of metals in your waste. So you have a colony of organisms, which are usually people use cow dung. They mix cow dung in the water and they provide air so that it gets the number of organisms multiply. And when your waste comes in, the organisms are selective in what food they want. I mean, some bacteria like some particular type of food. So, for gold, I think there are certain things which are selective also, selective organisms. So, what is the exact selective organism? We'll have to find out, and maybe introduce that organism in the extraction process. But then it is consumed by the bacteria, and then you have to extract it from the bacteria, I think. I really have to read down into the bioabsorption process.
Yeah, and maybe identifying the bacteria somewhere close to the gold mines or something may give the bacteria that has affinity to gold.
And one question was, I mean, I found it very, in the first class, in the first week, there was a discussion about silver being a pollutant. Silver. But silver is consumed by us. We eat silver. In the streets, which we buy, the silver foil is basically made of silver. It's basically silver paper. So how could it be a pollutant? It's not understand. I couldn't understand that.
Maybe in combination, because in e-waste we have in combination with many other metals.
Okay.
Because we have lead for soldering, arsenic and all. So maybe combining it with all that, it becomes a pollutant. Okay, so what shall we do? Should we discuss or close the session?
Ma'am, I request you, ma'am, please give us some more question bank, ma'am, because 20 questions or 10 questions, they are very less, ma'am.
Okay, I'm trying to get some questions, but the thing is, even I'm not able to get a full set of questions. So one thing, that risk assessment I could share with you. In that, many practice questions are there. So that is the most biggest topic that will have problems. So others are all mostly conceptual wise. So that should be okay.
So, ma'am, I request you, ma'am, please give us some more question bank, ma'am.
Okay. Okay. Okay, if there are no further things to discuss, can we close it?
Yes, ma'am.
Okay.
Thank you, ma'am.
Yeah, thank you.